Find the interval of convergence and the radius of convergence for the given power series. We have the sum from n equals 1 to infinity of the product of n squared and the nth power of x plus 2 divided by the product of 8 to the power of n and n to the power of 8/3. Notice we can simplify this formula because we have n squared in the numerator and we have n to the power of 8/3 in the denominator. Let's simplify this formula before we go any further. Recall when dividing and the base is the same, we subtract the exponents. N squared divided by n to the power of 8/3 equals n to the power of 2 minus 8/3. And 2 is equal to 6/3. 6/3 minus 8/3 is negative 2/3, giving us n to the power of negative 2/3, which equals 1 divided by n to the power of positive 2/3. We can write the given power series as the sum from n equals 1 to infinity of the nth power of x plus 2 divided by 8 to the power of n times n to the power of 2/3. Let's use the power series in this form. From here, notice because of the nth power of x plus 2, which we can think of as the nth power of x minus negative 2, the power series is centered at x equals negative 2, or using the form shown here on the right, this indicates c equals negative 2. And now to determine the interval of convergence and the radius of convergence, we'll begin by applying the ratio test, where a sub n is the given formula, and a sub n plus 1 is equal to x plus 2 raised to the power of n plus 1 divided by 8 to the power of n plus 1 times the quantity n plus 1 to the power of 2/3. And that's determine the limit as n approaches infinity of the absolute value of the quotient of a sub n plus 1 and a sub n. This gives us the limit as n approaches infinity of the absolute value of, first we have a sub n plus 1, which again is the quantity x plus 2 to the power of n plus 1, divided by the product of 8 to the power of n plus 1, and the quantity n plus 1 to the power of 2/3. Because a sub n plus 1 is a fraction, and so is a sub n, instead of dividing by a sub n, let's multiply by the reciprocal, which would be 8 to the power of n times n to the power of 2/3 divided by x plus 2 to the power of n. And let's begin to simplify. X plus 2 to the power of n plus 1 divided by x plus 2 to the power of n simplifies to 1 factor of x plus 2 in the numerator. 8 to the power of n divided by 8 to the power of n plus 1 simplifies to 1 factor of x in the denominator. From here, let's write x plus 2 divided by 8 as 1/8 times the quantity x plus 2, and then we still have times n to the power of 2/3 divided by n plus 1 to the power of 2/3. Notice both n and n plus 1 are raised to the power of 2/3, so let's write this as the limit as n approaches infinity of the absolute value of 1/8 times x plus 2 times the quotient of n and n plus 1 raised to the power of 2/3. In this form, we can find the limit. Notice n and n plus 1 have the same degree, which indicates as n approaches infinity, n divided by n plus 1 approaches 1, and 1 to the power of 2/3 is still 1, and therefore the limit is equal to the absolute value of 1/8 times x plus 2, or if we want 1/8 times the absolute value of x plus 2. From here, because we're using the ratio test, we know this limit must be less than 1 in order for the power series to converge, which gives us the inequality 1/8 times the absolute value of x plus 2 less than 1. And now we'll solve the equation for the absolute value of x plus 2 by multiplying both sides by 8, which gives us the absolute value of x plus 2 is less than positive 8, which indicates the radius of convergence is 8. Let's go ahead and record this below. We have r equals 8, which means we know for sure the power series will converge over the open interval from c minus r, or negative 2 minus 8, to c plus r, or negative 2 plus 8, which gives us the open interval from negative 10 to positive 6. But we still don't know what's happening at x equals -10 or x equals 6. We'll have to test these values and see if the power series converges or diverges at these values. Let's do this on the next slide. Let's first determine if the power series converges at x equals -10. We'll use a simplified power series formula. So we have the sum from n equals 1 to infinity of, subbing in -10 for x, we have -8 to the power of n divided by 8 to the power of n times n to the power of 2/3, which we can write as the sum from n equals 1 to infinity of -1 to the power of n times 8 to the power of n divided by 8 to the power of n times n to the power of 2/3. In this form, we can simplify. 8 to the power of n divided by itself simplifies to 1. We now have the series, the sum from n equals 1 to infinity of -1 to the power of n divided by n to the power of 2/3. Because we have an alternating series, let's apply the alternating series test. Recall there are two conditions. First, the limit as n approaches infinity of a sub n must equal 0. In our case, a sub n is a non-alternating formula of 1 divided by n to the power of 2/3, which is equal to 0. And we also have to verify that a sub n plus 1 is less than or equal to a sub n, meaning the non-alternating terms are decreasing. Well, a sub n plus 1 is 1 divided by the quantity n plus 1 to the 2/3, and a sub n, of course, is just 1 divided by n to the 2/3. Because 1 divided by the quantity n plus 1 to the 2/3 has a larger denominator, 1 divided by n plus 1 to the 2/3 will always be less than or equal to 1 divided by n to the 2/3, which means the series converges at x equals -10. So for the interval of convergence, we know the interval is going to be from -10 to +6, but now we know it includes -10, so the interval is closed on -10, and now we need to test whether the series converges at x equals 6. At x equals 6, we have the sum from n equals 1 to infinity of +8 to the power of n divided by the product of 8 to the power of n and n to the power of 2/3, which once again simplifies to the sum from n equals 1 to infinity of just 1 divided by n to the power of 2/3, which we should recognize will diverge by the p-series test, where p equals 2/3, which is less than or equal to 1. Now we know the series diverges at x equals 6, which means we don't include 6 in the interval of convergence, and therefore the interval is open on 6. Now we have the radius of convergence and the interval of convergence. I hope you found this helpful.